So today's webinar will be kind of a follow-on to our webinar a couple weeks ago about high-level risk assessments. And this webinar will specifically be focusing on how we can use the exSILentia Cyber tool to model these risk assessments and kind of prepare ourselves for the upcoming lifecycle tasks. My name is Patrick O'Brien, and I am a safety and cybersecurity engineer with exida. My background is in chemical engineering, but through exida, I've kind of developed experience in various roles, both supporting cybersecurity consulting as well as process safety consulting. I've also helped with the product development and a number of different knowledge content development projects, such as the cybersecurity book. Just a little bit of background on exida. We're a customer-focused company, and we try to really help our customers achieve both safe and secure solutions through three main areas. The first of which is enterprise tools, and this is specifically referring to our exSILentia tool, and this helps users complete tasks both in the safety and cybersecurity life cycles, and we'll be able to take kind of a little bit more of a deep dive on that today. We also support with certification and assessment. So we are an ANSI accredited certification body for a number of functional safety and cybersecurity standards. And then lastly, we do provide lifecycle services. So support for end users to ensure that they are kind of able to design and maintain their systems in a safe and secure manner. exida is a global company, so we are located really all across the globe. We have an office at each of these locations, and we are also supporting a wide variety of industries. So not only the chemical industry, but also oil, both up and downstream. We support a good deal of alarm management projects, as well as power and automotive. When we talk about cybersecurity, there are a couple of specific areas where exida can help. So these include our consulting services, certification to the IACS 62443 standard. We have a wide variety of training courses relating to cybersecurity. We also have the exSILentia Cyber tool that we'll look at today that can help complete lifecycle tasks. And finally, we have a number of reference materials. So the three main topics that we will focus on today are going to be the high-level risk assessment example that we discussed last time. Then we will focus on using the high-level risk assessment actually within the CyberPHAX tool. And finally, we will look at the exSILentia platform and the CyberPHAX demo. So we're going to do just a real quick bit of review on what we discussed at our last session. And I want to try to get an idea of how many people were there for that previous high-level assessment webinar. So if you could please fill out that poll now. We'll take responses for about 30 seconds, and then we will move forward with the presentation. Okay, so thank you guys very much for those responses. It's definitely helpful to see. So we can see that, I guess, a little bit over half of the people were at the previous webinar, but we still have a very large portion that won't. So when I go through and do the recap, I'll try to make sure that I provide everyone with enough information without going, overkill for the people who have already seen it. So just a brief background on really kind of understanding this approach to cybersecurity. It is really fundamentally facility risk management. And so, both for safety and cybersecurity concerns, it really comes down to understanding the applicable standards and taking steps throughout the entire life cycle of the process, both in the analysis phase, the design phase, and then through operations and maintenance. And so when we look at this for cybersecurity, we're focusing in specifically on the countermeasures and how we can use those to reduce our cybersecurity risk. The lifecycle standard that kind of has developed and documented these steps is IEC 62443. And a couple of important notes on this standard are that it is really owned by both operations technology and informations technology. So it's really important that these two groups are able to come together and actually ensure that the cybersecurity risk reduction is achieved. And again, so this scope includes the assessment phase, the design phase, and the maintenance phase. One quick example that really highlights why this is so important is actually back from August of 2017. And this was an attack on the Sadara Petrochemical facility in Saudi Arabia. The Sadara Petrochemical facility is a joint venture between, I believe, Saudi Aramco and Dow Chemical, and it is a large kind of refining company working with petrochemicals. And previously in 2012, there were a series of attacks that were called the Shamoon attack, and this attack was responsible for kind of locking out hard drives for enterprise machines and erasing a significant amount of data. So this caused kind of a very severe business upset for the companies, but it did not really have a severe impact on the actual physical input-output, so the actual valves or controllers so much for the facility. So when this attack began in 2017, it was originally believed to just be a second wave of this attack. But as investigators went in and kind of did a more thorough review of the code, they found that within this second string of attacks, there's actually one attack that was trying to cause a deadly explosion. So manipulate the physical plant in such a way that the process equipment would fail and there would be an explosion that would likely have multiple fatalities. And just a couple of really key notes, in addition to the fact that this was very nearly a safety consequence, was that the attackers were able to remotely overcome a physical lock and key system for the controller. So this was a Triconix controller that had a configuration switch. So the idea was if the configuration switch was turned off, there would be no way to remotely download a configuration or update the code on the controller. But investigators found that the attackers were able to download malware onto the system that then kind of overcame the security feature, and they were able to remotely gain control of this controller. And luckily, there was a bug in the attacker's code which resulted in a process shutdown before the deadly explosion was caused. But this is a very serious example of how attackers can go in and try to cause safety consequences for facilities. When we look about the ideas of what contributes to a successful attack, it's three factors. So it's the threats that we are susceptible to, so both internal threats, such as disgruntled employees, or external threats, considering kind of nation-state level attackers to general hacktivists, a wide variety of external threats. In the Sadara Petrochemical facility example, the threat was likely a nation-state actor due to the complexity of the attack. The next is the vulnerabilities. And so these are understanding kind of what holes are there in the operating model for security for a facility, and also holes in the actual software or hardware of the network devices. And so each of these holes or vulnerabilities really provides attackers with an entryway into the system and allows them to overcome security features. So the actual vulnerability or how the attackers were able to get onto the Triconix controller has not yet been released, but the key is that there was some hole where they were able to exploit it and overcome the security feature. And then the last feature is target attractiveness. And this boils down to what really would lead either an internal or external threat to target a system. And this could be how valuable that target is for political motives, economic motives, or personal motives. And so each of those kind of can provide different reasons why a facility might be targeted. For IACS security incident data, although we do spend most of the time discussing the intentional attacks, such as the Sadara facility, the majority of attacks are unintentional. And so these unintentional attacks include general malware being installed on the control system, concerns with either network devices not providing certain access, or also potential errors with the configuration of the codes where an operator may accidentally shut down part of a system or configure something in a way it was not intended. In order to make sure that facilities are prepared both for the intentional as well as the unintentional attacks, we have kind of this lifecycle approach to really go through the assessment, design, and maintenance. And specifically when we consider risk assessments and what steps we can do to identify and mitigate these risks, there are 3 steps. The first is the high-level risk assessment, which we'll be focusing on today, and this allows us to scope the critical assets and also get an idea of what the scope for future projects will be. It allows us to establish our initial zone and conduit diagram, and provides a lot of really good benefits for the detailed risk assessment and the security level verification activities that we will perform later. So when we go through, we're going to be working with an example chemical plant and go through the steps for a high-level risk assessment. And this high-level risk assessment, there are a number of inputs, including the PHA hazards, the device inventory, as well as the corporate risk criteria that are being used for the evaluation. So once this information is gained, there are 4 steps then that we will follow through. The first is documenting the worst-case scenario for each device. Next, we will determine what the security level target for each device should be, assuming that there's a likelihood of 1 for the threat. Then we will determine which devices have similar security level targets, and we will group them into zones that we can then separate from other zones. And then we will document really what the initial response to cybersecurity incidents should be. This will in turn then kind of scope what we need for our detailed risk assessment and security level verification. So the chemical facility that we will be using in this example is a styrene production plant. And the purpose of this plant is to convert 1,3-butadiene to styrene. And throughout this reaction, there are a number of different process areas. The first would be isolating the reactants for our reactor. So making sure that we have kind of high purity 1,3-butadiene to react. And then there is a 2-stage reaction. So the conversion of butadiene to styrene has occurred through 2 different steps. And lastly, we need to kind of purify and separate our product from other side products. And this would be an example of just a medium-sized styrene facility producing 60,000 pounds per hour of high purity styrene. When we look at a simplified block flow diagram for our facility, we can get kind of a quick understanding of what the different areas are. So our reactant isolation will occur during extractive distillation. So a number of distillation columns to separate out our 1,3-butadiene. We'll have our first reactor where vinyl cyclohexene is produced. And so this is in the intermediate in the reaction. So once this is separated, oxygen and steam can be added. And then that allows for the styrene reaction to take place in our second reactor. This is then separated through a number of steps, including a 3-phase separator to remove the water and the gaseous components. And then finally, a series of distillation columns are used to achieve high purity styrene. When we look at this process, we can see that there are a number of PHA concerns that were identified. And the first set of concerns that we need to think about are what chemical component concerns are there. So this plant includes 1,3-butadiene, a number of alkanes and alkenes. We also have vinyl cyclohexene, which is our intermediate. We've got high purity oxygen, steam, and then we have styrene as well as a number of side products that are formed in the second reaction. When we look at these, we want to kind of consider, so what unintended reactions could occur? And the first one we've kind of touched on is the fact that in the second reactor, there are a number of other products formed. An additional unintended reaction in this scenario is the violent reaction of 1,3-butadiene with oxygen. So although 1,3-butadiene is our initial reactant, if any is present when we move on to the second phase of the reaction where oxygen is introduced, there's a potential for a very violent and very dangerous reaction. So this is one concern that the plant really has to be active in addressing. Additionally, the vast majority of chemicals in this plant are highly flammable. Many of them are toxic, and a few are corrosive, particularly the benzoic acid that's formed as a side product. So having a basic understanding of the chemistry behind the plant is important to make sure that when we go through and perform our high-level risk assessment, that we know what we're addressing. And then lastly, you need to understand really what the effects of high pressure, high temperature, potential for a runaway reaction, or the existing safeguards. And so this really is what we need to do when we're looking at specific units and understanding what could go wrong. Additionally, we need our device inventory or our network components. And so for our example, we have kind of just a very simplified system, but we have some enterprise workstations. We've got a number of servers with different purposes. And then we also have our basic process engineering workstation, which is connected to our PLC, as well as an operator workstation. And then lastly, we have our safety system engineering workstation and our safety PLC. When we go through and look at this example, it's important to consider really the full impact that it could have on each of these systems. And so we will specify the consequences and the, really the understanding of each of those devices, considering the full realm of possible consequences. So these could include consequences to the safety of the personnel, both on-site and off of site, how that affects the public image of a company, damage to the environment, damage to equipment, and also the financial cost of lost production. The outcomes of the high-level risk assessment are to make sure that we're aligned with corporate risk criteria, that the highest areas of risk have been identified, and then to develop a segmentation strategy so that our network is maintained in a secure manner. We want to do this to really make sure that we're supporting the subsequent lifecycle tasks and that we can respond effectively to incidents if they occur. So this can really be summarized as two goals: to reduce the likelihood of a successful attack and to ensure that we're able to recover as quickly as possible from an attack. And this is important to understand because with cybersecurity attacks, it's not really a question of if so much as a question of when. So if an attacker is motivated to get into a system, countermeasures will make it more difficult for them to achieve and may limit what they're able to do on the system. But eventually, as we've seen, even with the Triconics controller where there's a physical configuration switch, eventually they will some way into the system. So not only are we trying to make that as difficult as possible, but we also need to make sure that we are recovering from these attacks as quickly as possible. So from there, what we're going to do is we're going to look at specifically how we can go through and model this high-level risk assessment using the CyberPHAX tool. And one thing that would be good to know is just kind of how familiar people are with the exSILentia platform. So please just take a second to fill out that poll now, and we will move forward into the example. We'll give it 5 more seconds and then we can share the results. So we see that we actually do have a very even split. So about half of the audience is somewhat familiar with the tool, while a quarter is not that familiar and a quarter is not really familiar at all. So that's good. So we'll be able to kind of look at overall what the tool can do and then specifically focus in and understand how it is helpful in high-level risk assessments. So first, when we look at the inputs for risk assessment, the tool can help in a number of ways. One of the ways is that we can define risk criteria within the tool. And this allows you to customize the tool to be compliant with corporate risk criteria. So throughout the entire evaluation, you're able to make sure that you're staying consistent with these risk criteria. And this supports really the use of example risk matrices. The device inventory can be documented in the tool, and we'll kind of see how you can add that. And also the PHA hazards could be documented in the FAX tool of exSILentia. So not the cyber-specific tool, but there's actually a tool designed to perform process and hazard analysis considering the safety consequences. Next, when we talk about documenting the worst-case scenario for each device, we went through and did this last time as we went through the example, just looking at, if we lost each device, if it was compromised, what would the overall consequence be? And so when we go through the tool, we'll do this more in depth, but just to show how it can be done, we'll look at a screenshot of the exSILentia tool on the next slide. But it's important to note that based on the specific tool or the specific devices, the consequences can be very different. For so the enterprise workstation, it's more of a business device, and so really we're only going to lose business functions. For the servers, if they go down, we'll lose kind of specifically that server function. So for our patch management server, we won't be able to patch the system anymore. For the maintenance server, we won't be able to really perform those maintenance functions. And then when we look at specifically the BPCS system, there's a potential that our BPCS controller could be compromised if our engineering workstation is compromised. And the same thing would go for the safety system. So if we look at the exSILentia tool worksheet, we can see that we can kind of specify the threat that we're looking at, and then also determine what the consequence would be and document that within the tool. The next step is to determine the security level target for each device, assuming a likelihood of 1. And so in our last example, we went through and ranked how severe each of the consequences would be, and this again is compliant with our risk criteria. So security level 1 would be minor business consequence, security level 2 would be more moderate business consequence or recordable injury, security level 3 gets into a significant business consequence with the potential for permanent injury or a single fatality, and security level 4 is going to lead to kind of a severe business consequence and the potential for multiple fatalities. When we look at documenting this in the exSILentia tool, we can see that we can define the likelihood, and so in our high-level risk assessment, we are going to assume a likelihood of 1, which is the high likelihood in the risk matrix and the likelihood matrix that we are using. And then we can specify the severity of the event with a security level target. So this kind of helps us to document just off of the consequence severity what security level we're going to need to target for that system. And this will automatically generate a risk number, which gives us an understanding of how much cybersecurity risk reduction is going to be needed. Next, when we group devices with the similar security level targets into segmented zones, as we went through the example, we saw that by adding a couple of firewalls, we could set up a demilitarized zone between the enterprise network and our control zone. So we grouped like devices together into one enterprise zone, a demilitarized zone, and then a BPCS zone and CIS zone, so that we actually had segmentation between our basic control systems and our safety systems. Within the tool, we can also kind of mirror this network segmentation strategy and make sure that when we are evaluating systems, we understand the connections between them and how they are separated. An important thing to note on this diagram is also the segmentation can be provided either by a firewall, as we see between the enterprise network and our demilitarized zone, or as is the case between the CIS zone and the BPCS zone, sometimes a managed switch can be used. And then what this does is it allows you to specifically route what traffic is allowed to travel between devices without using a firewall. And so sometimes that can be a good thing to use for more of the control level side of things. And when we move to looking at this in exSILentia, we'll be able to see kind of how we are able to kind of model these each of these devices together. And so what we will do is we'll kind of specify which zones we have, and then we will define cyber nodes within each of these zones. Sorry, give me 1 second to get the PowerPoint back up and running. Okay, So when we go to look at the worksheet in the tool, we can see that we have a hierarchy that allows us to specifically define each of these zones that we were evaluating. So our enterprise zone, which includes our enterprise workstation, is specified as a zone. We can have a demilitarized zone where we evaluate both of our devices in that zone. We can evaluate our engineering workstation, our PLC, and our operator workstation in our BPCS zone, and we also will have a separate safety zone that we can look at. And so what this does is this really sets the framework for our detailed risk assessment, so that when we identify the high areas of risk in the high-level risk assessment, we can have them documented and go through and consider each specific device within that zone. The last step in the high-level risk assessment method is to document the initial response to cybersecurity incidents. And the goal of this is to restore operations as quickly as possible, communicate with relevant stakeholders, keep data for the incident, report it as needed, and make sure that we kind of know what steps we need to take to avoid future incidents. The tool also allows you to kind of easily document what your initial response plan should be for each node, considering the consequence. So if we look at our safety consequence, we may know that we need to kind of either shut the process down if we do not have other means of risk reduction, or in the case where we have other countermeasures and safeguards that we can deploy to try to maintain the process in a safe state, we would be able to isolate that system, repair it, and then return it back online without unnecessary process downtime. So this allows us to document that specifically for each countermeasure, for each device, so that when we go through and really run into a concern, we know what actions to take. The tool also allows us to define the scope for our further lifecycle tasks, as well as easily document results to share among an organization. And so from our high-level risk assessment, we really want to make sure that we're able to populate our detailed risk assessment, as well as have the information that we will need later in our security level verification. The tool allows us to do this very easily, and not only does it allow information to flow directly from the CyberPHAX report to CyberCell, we also can generate reports that kind of document what high-risk zones were identified, the initial security level targets that were defined for each zone. We can kind of keep track of our network segmentation strategies, so understanding what zones and devices within these zones our plant is separated into. And then we also can have a list of recommendations, which from our high-level risk assessment would include all of our emergency response plans per device. And the exSILentia platform kind of supports this in a number of ways. The first of which is knowledge capture. And essentially what we're trying to do is provide embedded databases so that it is easy to access data once it's been defined and it's traceable. So you can go back through projects and understand specifically what the CyberPHA team or the CyberSL team was considering. This allows us to use libraries and easily share information across the different modules. We have specific user-defined project configuration, so we are able to define exactly what type of systems you want to be looking at, as well as define what risk configuration is necessary. And then as we saw on the last slide, there's a suite of predefined reports that allows us to really share this information and easily communicate it. The data core really focuses on kind of storing these user inputs and enhancing the libraries. So this allows for quick references, reuse, and easily reusable information. So we can reuse threats, countermeasures, cyber event scenarios, recommendations, all within a project. So it really helps us to move at really a quicker pace and make sure that we're efficiently and effectively documenting our cybersecurity concerns. There are also project-specific definitions, such as the likelihood and severity for our risk matrix. And this allows us to be consistent both with company standards and just overall good engineering practice for following tolerable risk criteria. And then lastly, these reports that are generated will capture this information and allow us to kind of easily communicate this. So now what we will do is go in and actually look at the exSILentia tool and work through an example of how we might complete a high-level risk assessment. So here we can see I've pulled up the CyberPHA worksheet within the exSILentia tool. And if we go back to the dashboard quickly, we can look at some of our project configuration options. So we can see that we're looking at our styrene chemical plant. We have a brief description. We can define what types of zones we want to consider. We can define the types of cyber nodes that we want to consider, and these will be both the specific devices that we are looking at, such as an operator workstation, an engineering workstation, and they can also be specific threat agents or types of attack that we want to make sure we're considering. So this allows you to be flexible when you go through and perform your risk assessments and really consider all of the threats necessary. When we look at plant types, we can also define kind of exactly what type of plant we are looking at. So in our case, we are looking at a styrene production facility. We can define what type of plant it is. We can enter a custom description, such as really what is done in terms of the reaction. So for our description, we would have 1,3-butadiene is converted to high purity styrene through a kind of a two-stage reaction and multiple purification steps. So that way we just have a really basic understanding of what we're looking at in our system, and this allows us to easily link to that. For our risk configuration, we can specify a custom cybersecurity risk matrix. We can consider business, environmental, and safety consequences, as well as the ability to add other risk receptors. So this could be specified to meet really any corporate risk criteria. If we, for example, also wanted to consider the impact of a cyber attack on public image, we could look at how that would affect the public's outlook for a company, whether that would have a negative impact on sales or on the software company, could be important to consider. For our severity levels, we specifically kind of define them as they relate to our security level targets. So this allows us to quickly define security level targets within our risk assessment. And this kind of builds a severity matrix where we have the severity level consequences mapped to each specific risk receptor. We can define our likelihood within the tool. So for cybersecurity, exida often recommends just doing a simple low, medium, high based on how likely it is. And all of this together really facilitates having a customized risk matrix that can quickly show you as you're moving through a worksheet whether you are kind of in a low risk zone, potentially the as low as reasonably practical zone, or an area where additional risk reduction is going to be needed. And so everything that we define here is captured as we actually work through the CyberPHA worksheet. If we look at our safety PLC example, which we were working with before in the PowerPoint, we can see, so we have the threat that we are concerned with, so installed malware on our safety PLC. We can see what the effect of that consequence would be. We are able to define, which risk receptor is targeted, and then finally we can document really what the severity of that attack is going to be. So that automatically generates our risk for us, and we can see, how high the risk we're dealing with is. For our recommendations, we can specifically define what our initial response plan should be, and this allows us to kind of quickly document all of that information. That will also allow us to then have this information available when we proceed with our detailed risk assessment and easily move that over to our safety PLC as a starting point. If we go back to our high-level risk assessment, we can then just kind of quickly work through some of these examples for our plant. So if we are considering our enterprise workstation, the threat would be in our high-level risk assessment, malware installed on enterprise workstation. And so if we consider really the likelihood of this, since we are in a high-level risk assessment, we're going to assume a likelihood of 1, which would be our high likelihood. When we add the consequence, we specified that this was really the loss of business functions, and this is going to give us really just a minor business consequence. And so what we're seeing here is the tool gives you autocomplete options. So if you've gone through and kind of defined specific things once, it will actually automatically suggest that for you, and it can be very helpful in typing quickly. So as a trial before this demo, I went through and added some of this stuff to the tool. So it's already letting me pull that back out and kind of automatically add it. For our consequence severity, this is going to be really a business impact. And as we defined working through the example, it's likely only going to be a security level 1. And so we can see that this is not as critical and is not going to be something that we necessarily need to review in our detailed risk assessment. If we then move to our patch management server, we can add another threat and look at really what our concerns are for the patch management server. So here we're really worried about malware being installed on the patch management server. This is also going to be defined with the likelihood of 1. For our consequence, we are going to have really kind of the compromise of patch management server resulting in loss of patching function. And this could potentially mean that we are unable to patch at specified downtime, resulting in diminished security and potential process downtime if we need to say shut down outside of what our predefined shutdown is. That may have a cost associated with it. But as we look through an example, this really is still probably likely only a security level 1, maybe at most a security level 2. So we could see that something defined as security level 2 maybe does have a higher risk and should be evaluated more. But if we do determine that it's only a security level 1, this may be sufficient. If we move and say look at our engineering workstation, our threat is going to be, again, malware installed on our engineering workstation. We can quickly select what our likelihood is, and then we can add a consequence. Now for the compromise of our engineering workstation, what we'll see is that there's the potential for malicious code to be installed on our BPCS PLC. And if this were to occur, we could see really some potential equipment damage, we could see loss of production, and we could also see potentially an unsafe situation leading to a runaway reaction and vessel rupture in our Styrene plant. So if we consider really the worst case scenario, there's the potential for safety consequences. This will give us a security level of 3, and we'll see that we do have a high risk that we want to mitigate. When we consider what our initial response plan should be, we really want to kind of document initial response plan for our BPCS. And so we are going to really want to kind of enunciate the cybersecurity event. Then we can take steps to isolate the BPCS engineering workstation from our controller. And so this is important because we want to make sure that even though the engineering workstation has been compromised, if it's not downloaded to our PLC controller, then we're going to be able to eventually prevent that unintended process downtime. If we see that the malware has been installed on the BPCS, we're going to want to gracefully shut the process down as needed. And lastly, we're going to want to investigate the incident and mitigate whatever remaining threat is there. And so that specifically will be our recommendation for if there's an a concern with the engineering workstation. What we can do then is, if we look specifically at our PLC, we can define that if malware is installed on BPCS controller, we'll have the same likelihood, the same, a similar consequence. So unlike in the BPCS example though, we're not gonna have to worry about really whether or not it goes from the engineering workstation to the PLC. Since the PLC is compromised, we kind of know that code is already on there. So we'll define our security level target, and then we can actually kind of link the recommended response plan, because we know that we're going to need to take similar steps if the controller or the engineering workstation is compromised. So that gives us another example to kind of quickly link information from one step to the next. So after we've gone through, we can really easily define what our security level targets are for each of these devices. And that's what the necessary input is to be able to kind of specify our zones and conduits. So when we define a zone in exSILentia, we can name it, we can specify what type of zone it is. So for our enterprise zone, we would see that it's an enterprise zone type. We can specify that we're in a styrene plant, which will give us kind of that information, that description tracked with it. And we'll see that we're in a continuous mode. So we've done this and added the enterprise zone with the relevant equipment, the demilitarized zone with the 2 servers, and the safety system with those 2 zones. And what we will do now is just look at how easy it is to add another zone and specify our BPCS zone. So when we are defining zone types, we're kind of going back and considering the Purdue reference model and understanding, their different layers, where we've got the enterprise zone at the top, and then the actual really cell and area zone on the physical level kind of represents the most basic control system. So for our BPCS, we're going to see that it's a cell area zone. We know that we are dealing with a chemical plant, and we know that we are working with a styrene production process that is continuous. So we're able to quickly define that and have all of the information that we need for our zone. We can specify cyber nodes. So our first cyber node is going to be our BPCS engineering workstation. We can specify what type of node it will be. And so for our engineering workstation, we have that available to us. And what specifying the node type will do is it automatically configures threat vectors that we are going to evaluate. And so these threat vectors are specifically what we'll look at with the detailed risk assessment, and they provide us with a more detailed ability to look at and understand the threats at a granular level. So although those aren't necessary for the high-level risk assessment, the tool will allow us to then go in when we use these zones for our detailed risk assessment. We can then quickly go through and add our remaining devices to this zone. So we've got our BPCS controller. For our zone type, we have the controller. And so again, we'll link those threat vectors that we need to be considering. And then our last device for our BPCS zone is going to be our BPCS operator workstation. And so in just a couple minutes, it's very easy to document. If we have all of the knowledge and inputs required, we can really go through, complete that high-level risk assessment, and then get an understanding of what our scope for the upcoming assessments are going to be. And so if we define that, we can also kind of use the navigation tree to rearrange this as we would like to look at it. So say we want to move the BPCS zone kind of where we have it organized between the demilitarized zone and the CIS zone, we can easily just drag it to where we would like to move it in our example. So just to kind of review what we were able to do, we went through and looked at the high-level risk assessment, going through and specifically defining the potential threats, what the consequences were. Then we looked at what the severity of the consequence was, determined our security level target. We documented our recommendations. And then lastly, we were able to segment all of our devices into the respective zones so that then when we go forward in our detailed risk assessment, we can evaluate them together and understand really how they are connected. So the last thing that we might do for our high-level risk assessment is generate a risk assessment report. And so what this will allow us to do is quickly share the results from what we've documented in the tool across the organization. And within this risk assessment, we get a number of helpful things, such as the risk matrix that was used. We can look at what specific recommendations were made. We can look at the specific segmentation of the zones and what devices are in each zone. So this documents our network segmentation strategy. We can have specific descriptions for what each zone is doing. We've got our references. Here we can see the risk matrix and kind of our severity and likelihood matrices. And then in our appendix, we'll document what recommendations are there, and then we can actually go through and specify. We'll actually share what the PHA worksheets look like, which will show us our severity level targets and really just the different consequences for each device. So now what we'll do is go right back over to the PowerPoint for our ending slides. And we'll have some time to go through some questions. So if you have any questions either on the method or on the use of the tool, please ask them now if you haven't already, and I'll take some time to review those. Okay, so I've got one question, which is how is, I'm sorry, let me pull it up. Okay, so someone is asking, it looks like when the presentation on the detailed risk assessment is going to be. And so what we'll do is that will be sometime either by the end of October or very early in November. So once we've scheduled the webinar, we'll send that information out and we will communicate that to you. But typically plan maybe on around 3 weeks or so, and we'll go in. And first we'll do the detailed risk assessment methodology, and then we will follow up and look at how it can be done in the exSILentia tool. So kind of following the same format that we did with the high-level risk assessment. And so a couple other things that we want to touch on just really quickly before we end the presentation today are really why it would be useful to go through and actually perform that high-level risk assessment in CyberPHAX. And so there are a couple of key things that we can see. We can make sure that we're aligned with our corporate risk criteria. We can make sure that there's a formalized methodology that is followed for our organization. So making sure that we are kind of consistently performing these evaluations. We can take advantage of these libraries and quickly access information that we've defined. We've got worksheets that are easy to use and flow through. So not only defining our threat, but going through consequence and severity level. And then finally, we have automatically generated reports that can share those kind of our results. And so we went through the example today, how to use the tool for it, and then what the exSILentia platform is. exida can help, again, in a variety of ways, both in our services, so performing these high-level or detailed level risk assessments, as well as a number of other lifecycle tools and activities, specific certifications for different organizations, including personnel certification, our number of training courses, and then specifically kind of what we looked at today, our cybersecurity tools, and exSILentia Cyber. So if you are interested in learning more, please ask questions for the remainder of the webinar session. You can also reach out if you kind of want to request maybe an exSILentia Cyber demo, or look at really how to use the tool for a specific problem or project. And we also do offer a number of other related services as well. So lastly, we do have some upcoming training. So if you're interested in training either for cybersecurity or any of our other related trainings, please see our website for our full list. And you can always follow us on Twitter, Facebook, or LinkedIn. So I think we've got one or two more questions that we'll talk about now. So this question is about kind of how information moves through the tool for the different the lifecycle tasks. So we know that there are 3 tasks that we want to complete in the tool. We've got our high-level risk assessment, our detailed risk assessment, and our security level verification. And to do this, the tool uses 2 modules. The first is the CyberPHA module, which we looked at today. And this is where we'll perform our high-level and our detailed risk assessments. And so we can kind of define them in the same worksheet as we saw, but easily move information from one to the other, so that we can populate our detailed risk assessment with the results of our high-level risk assessment. And then when we actually go in and perform the detailed risk assessment, we have the ability to kind of pull all of our countermeasure and threat-specific data over to the security level verification. So that is a good question, because it's really important to see that the tool is designed to match the life cycle and can allow us to move information over effectively. So I don't see any other questions right now besides those 2. So if you have more, please don't hesitate to put them in there. If not, thank you guys very much for joining me for the webinar, and thank you for your attentive responses to the polls. That's always helpful. All right.